Okay, Algebra 2, welcome. This video, Chapter 1-5, Absolute Value Equations and Inequalities. The absolute value of a number is its distance from 0 on a number line. As you'll see on my number line below, if I put a dot at 7 and graph the number 7 on a number line, 7 is 7 units from 0. Also, if I graph the point -7, -7 is also 7 units from 0. Since they're both the same distance from 0, then that means they have the same absolute value. So for absolute value, we get two values. Okay, let's work an example. An absolute value equation like the one below has two solutions, since the expression 2y minus 4 can equal both 12 and -12. Okay? Now this one's already worked out for you, so I'll walk you through it real quick. Alright. 2y minus 4 equals 12, absolute value. What we do, since we've got to have two values, we've got to have both the positive and the negative, we have to work each equation out twice. Okay? We will work each equation out twice if it's an absolute value equation. The first one will read exactly like it is written. 2y minus 4 is equal to 12. And guys, y'all should be able to solve this mini math now. We've done many of these already. But we'll add 4 to both sides. Cancel. 12 plus 4 is 16. Divide by 2. 16 divided by 2 is 8. And as you'll notice, I've already checked this one, so let me walk you through that. 2 times 8, 16. 16 minus 4 is 12. And the absolute value of 12 is 12. Check. Okay. The second equation will read, and I'm going to clean it up a little bit since it's already worked for y'all. We'll start over. The second equation will read 2y minus 4 is equal to -12. So you set the first one up in blue, 2y minus 4 equals 12, just like it's written without the absolute values. And the second one is 2y minus 4 is equal to -12. You will do this every single time on an equation. Now sometimes the right side looks a little worse, but that's okay. We'll learn how to deal with it. Okay? So go through it again, solve it, divide by 2, and everything else is fine. Y is equal to, and I made a boo-boo on my earlier problem. Some of you guys has probably already seen that. 8 divided by -2, I'm sorry, 8 divided by 2, -8 divided by 2 is -4. Okay? Now, let's check this one together. 2 times -4 is -8. -8 minus 4 more is the absolute value of -12. And the absolute value of -12 is also 12. So both of these check out. Alright guys, I got you one ready to roll here. Student example, absolute value of 15 minus 3x equals 6. Now would be a great time to pause the video and work it out, and we'll check it out in a minute. Alright, let's see how you did. First one, we'll set it up twice because it's absolute value. 15 minus 3x is equal to 6. Absolute value. So the first one, 15 minus 3x equals 6. The second side, 15 minus 3x is equal to -6. And then we just solve the two-step equations simultaneously. Subtract 15 from both sides. -3x is equal to -9. You then divide both sides by -3. Cancels out. Negative divided by negative is positive. X equals 3. And if you checked it, 15 minus 3 times 3 is 9. 15 minus 9 is 6. And the absolute value of 6 is 6, so it checks. Okay? Let's check the next one out. 15 minus 3x equals -6. Alright? Subtract 15 this time, you get -21. Divide by -3. Negative divided by negative is +7. So my answer on this one was +7. Alright, let's check it now. +7. 15 minus 3 times 7 is 21. 15 minus 21 is -6. And the absolute value of negative 6 is positive 6. So it checks. In both of the previous examples, the one I worked and the one you worked, both answers worked when you went in to check them out. But sometimes you'll find a solution that will not work. In that case, you have found what they call an extraneous solution. Extraneous solution. You'll see that in your vocabulary, in your book. An extraneous solution is one that is obtained from the original equation, but it is not an actual solution to the equation. Okay? I'm going to work you guys an example and show you guys an example of an extraneous solution. Okay? All right. You ready? I'm going to move this over just a little bit, center it up. All right. I also would like for you guys to recognize one more thing. That is, we've got a binomial on the right side of the equation. So be careful, take good notes, and watch what happens when I make both of my equations. I'm going to stick with my guns on this. The first thing we're going to do, set your first equation up on the left, just like it reads. 2x plus 5 is equal to 3x plus 4. Okay? Let's show all of our work here. You guys are getting good at this, solving equations by now. We'll subtract 5 from both sides now. See you later. And negative x is equal to negative 1. So, if negative x is equal to negative 1, then that means x must be equal to positive 1. Alright, let's throw this in our equation up here and see if it works. Absolute value, and I'm going to write this whole deal out. So we're checking our answer now. 2 times 1 is 2 plus 5 is equal to 3 times 1 is 3 plus 4. Absolute value of 7 is 7. So this guy checks. Okay? Now pay attention to what happens on the right side this time, guys. I'll work it in all red so y'all know what to call this one. Caution. Okay? Alright. So this is all kinds of trouble here. The left side reads just as it is written in the original equation. But watch the right side. 2x plus 5 is equal to negative. But this time we've got a binomial over there. So we've got to pay attention and deal with that. Okay? If it's a binomial, we have to change both sides. I'm sorry, we have to change both terms. Change the sign of both terms. So we'll go 2x plus the 5. Before we can do any work, we got to change these signs. If you guys will remember, it's just like distributing a negative 1 right there. Okay? Let me erase that. So it's just like distributing a negative 1 right there. Okay? Now we'll just solve the thing again. Uh-oh, I'm sorry. 3x. We'll add 3x to both sides. History. There's 5x plus 5 equals negative 4. Okay? Minus 5. Minus 5. You get 5x equals negative, and negative is 9. That'll be negative 9, won't it? Okay? And then we divide both sides by 5. Divide both sides by 5. And x equals negative 9 fifths. Alright, now for the fun part. We get to check this fraction now. But we don't worry about fractions in here. I may not have enough room here, so y'all watch closely. 2x, and I'm going to plug in my negative 9 fifths in there. Alright, and I'm going to add 5 to it. Alright, set her equal. Now you've got 3x And I'm going to plug in my negative 9/5 in there again. Sorry about that being so sloppy, but I'm trying to write it's a little smaller. Alright, here we go. See if we can show a little bit of work in here while we're checking. That's negative 18/5. I'm not going to call this 5. I'm going to change it to something over 5. 25/5. Absolute value. Okay, keep that in mind. We're still doing absolute value, guys. Alright, 3 times negative 9 is negative 27/5. But I'm not going to call it 4 because we got to get a common denominator, guys. Remember, I'm trying to get you guys to not worry so much about your fractions, okay? So I'm not going to call it 4. I'm going to call it something divided by 5. Alright, that'll be 20/5. Alright, watch this. If y'all can read my sloppy writing. Negative 18/5 plus 25/5 is positive 7/5. Keep in mind, we are still inside absolute values. The absolute value of no number will ever give you a negative result. And if you'll notice, negative 27/5 plus 20/5 is negative 7/5. So, here's the deal. This entire right side number just did not work, okay? It just did not check out. That's what we call an extraneous solution. It's a solution to the equation, but when you plug it back in, it does not work, so it's not an actual solution. So in example 2 here, we only had one real solution, and that's x equals 1, okay? That was a tough check, but we made it work. Let me let you guys try one. Alright, down here at the bottom, you got the absolute value of 3x minus 4 is equal to the negative 4x minus 1. I'm going to let you guys just check her out right there. I hope you paused it and tried to work it yourself. But here's the way it sets up. First one, once again, I'm going to highlight everything this time. The left side, if you'll notice, looks just like the original equation without the absolute values. The right side is the same thing except we changed the sign. On this one, you got to be careful because I had the minus. Once again, it was a binomial. And my equation has slid off the page, so I'm going to move everything over just a little bit for y'all. Okay. There we go. That should be good. So anyway, we're changing the binomial now. The opposite of negative 4 is 4. The opposite of negative 1 is positive 1. You solve them both times. And guys, I'm going to let you guys check them. And we'll start there and we'll check that one in class. This video is getting a little lengthy now. So I'm going to do this one last problem real quick. I've got to show you one more thing, okay? Okay. Solving absolute values that are inequalities. You remember when we worked equations in chapter 1.3, 1.4, and then all of a sudden we swapped gears and we went to inequalities? Well, same scenario. Now I've added a little twist on this one, and this might be some you want to ask me about tomorrow in class, but I'm going to let you guys look over them in the homework set tonight. I'm going to go ahead and bring me a number line up here because we're going to, with inequalities, the main difference with inequalities versus equations is you have a bigger solution set because inequalities don't have an equal sign. They have an inequality symbol. This time it's less than. Alright. Pay attention here. This one's got all kinds of funky little things about it. Here we go. Alright, the first thing I got is 3 times absolute value of a bunch of stuff minus 9 less than 15. This kind of works like your old equations you learned way back in pre-algebra. We're going to add 9 to both sides first. So you can simplify absolute value equations just like you can simplify regular equations. Okay, I believe that gives us 24, right? Since this is 3 times, you guys should know how to undo a multiplication by dividing. As long as you do it on both sides, it's legal. And 24 divided by 3 is 8. And you guessed it, guys, and there's one more little thing I got to tell you here, okay? These are so much like equations, except for one or two little things. We've got to still got to solve it twice, just like we did a while ago, and just like we did a few minutes ago. The left side will read just as it is written in the original equation. So 2x plus 6 will be less than 8. We'll subtract 6 from both sides. Da 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 da. Y'all know how to do all this now. Alrighty. Divide by 2. Divide by 2. And x is less than 1. Okay? We can put that on our number line. I'll do it. I'll graph these in just a minute. Move this up just a little bit now. Alright. Watch the right side though. And once again, this is the scary side, so we'll make it red. Alright. 2x plus 6 is less than 8, and 2x plus 6 is greater than negative 8. Not only do you change the sign, you know, it was positive, we changed it to negative, but you flip the inequality symbol. Okay? So 2x plus 6 is less than 8, and 2x plus 6 is greater than negative 8. And now you just solve it just like you normally would. Pay attention to all the regular inequality rules that we went over in class just a couple of days ago. Alright, we're going to divide both sides by 2, and x is greater than, I don't know what happened to my x there, is greater than negative 7. Okay? Alright, left side we'll graph it black. It's at 1. That'll be an open dot at 1, and it graphs to the left. Okay. The red one, open dot at negative 7, and it graphs to the right. Now, next question, is this an and or an or problem? And since the solution sets overlap each other, this one would be an and problem. Alright, good job, guys. Homework set.